Okay, I hope I'm audible to all my students who are attending this online lecture for the introductory mathematical methods for economics offered in semester 1 of BA Honors Economics at Delhi University. This is Akshay Sir from the Divine School of Economics. Okay, what you can see on your screens is the 2025 question paper, which has come up at Delhi University for this particular course, which is your Introductory Mathematical Methods for Economics. Okay, we are going to start our discussion of this particular question paper. I'm going to solve each and every question in depth. Okay, but remember that in order to start practicing the past year papers, it is very important that the students have gone through the content. You have gone through the concepts before. Okay, in my introductory mathematical methods for economics course offered at Delhi University in semester 1, I cover each and every concept in detail using the Sater and Hammond book, which is one of the major books we follow for our introductory mathematical methods for economics. Okay, alongside that, I will be solving each and every question of this latest past year paper. Okay, so you can quickly look at the instructions first of all, especially students who are watching this lecture for the first time. The name of the paper is Introductory Mathematical Methods for Economics. We also call it as MME1. Okay, it's a 90 mark paper, semester 1. You can check out the paper code. You have 3 hours to attempt this paper. Okay, and there are 5 questions which need to be attempted. Okay, so in totality you have 6 questions. Okay, and you need to attempt any 5 questions. All parts within each question carry 6 marks except where the marks of a part are specified. So almost every question, or I can say almost every part within a question, is for 6 marks. Okay, so in this online lecture I'm going to start with the discussion of question 1. Okay, and I'm going to solve parts A and B in this online lecture. So let's quickly start with the discussion of question 1, part A and B in this lecture. Let's look at question 1, part A. Use the technique of indirect proof to prove that for two integers x and y, if xy is even, then either x is even or y is even. Now, in my lectures on preliminaries, we talked about set theory, we talked about symbolic logic. Okay, and in my lectures on symbolic logic, we have looked at how to do or how to prove a proposition using direct proof, using indirect proof, and using proof by contradiction. Remember, whenever you have to prove an implicative statement, you can prove it either using direct proof or indirect proof or proof by contradiction. And I have done this in quite depth in my lectures on symbolic logic within the preliminaries module. If I come to the whiteboard to solve it, I am first of all writing the main heading for clarity. This is Delhi University. We are talking about economics honors. This is semester 1. Okay. Name of the paper is Mathematical Methods for Economics, Part 1. Or we can also call it as Introductory Mathematical Methods for Economics. This is the 2025 question paper we are looking at. And within this question 1, part A. Okay, so our implicative statement is what? Our implicative statement here is, remember, implicative statement in general is P implies Q. How do I read it? If P, then Q. So in this case, my statement P is XY is even. X into Y is even implies that either X is even or Y is even. Either X is even or Y is even. I need to prove it. And the method we are going to use, the question has asked us to use indirect proof. Now, how do I use this technique to prove this particular statement? Now, in general, I can say that P implies Q. Okay. The indirect proof for this is the indirect proof for this implicative statement. The indirect proof for this implicative statement is not Q implies not P. So if I prove that not Q implies not P, I automatically prove that P implies Q. That means, what do I need to show? I need to show that let X and Y be not even. It means that XY should also not be even. This is P, this is Q. What will not Q be? Not Q will be X and Y are not even. Q was either X or Y is even. So not Q is X and Y are even. Not even. X and Y are not even. What will not P be? XY is not even. That means, what do I need to show? I need to show that if X and Y are not even, then it implies that XY is also not even. If I show this, I show not Q implies not P. And if I show not Q implies not P, I automatically show that P implies. This is the indirect proof technique. Now let's start with X and Y are not even. So suppose X and Y are, so I can say let X and Y be not even. Let X and Y be not even. That is, let X be equal to 2n plus 1 and let Y be equal to 2m plus 1, where both m and n are integers. M and n belong to set of all integers. Remember, Z denotes set of all integers. We covered this in our set theory course. Okay. Now, if I take their product, so X into Y will be 2n plus 1 times 2m plus 1. And if I open up the brackets, it's going to be, I can write this as 4mn plus 2n plus 2m plus 1. And students, within this, I can take 2 common. So 2 times 2mn plus n plus m plus 1. Now you can see this is also an odd number because it's 2 times something plus 1. Remember, this whole thing is even and this is odd. And we always know that even plus odd is always odd. An even number plus an odd number is always an odd number. So I have shown that therefore X into Y is odd. That is, it is not even. So what have I shown? We have shown that if X and Y are even, if X and Y are not even, this is what we have shown. If X and Y are not even, then XY is also not even. So I have shown that not Q implies not P. Therefore, by indirect proof, P implies Q. That is, if either X or Y is even, or I can say, what was P? P was, the statement P was XY is even. The statement P was XY is even, which implies, what was the statement Q in the beginning? The statement Q was either X is even or Y is even. So I can write either X is even or y is even. So we have proved it, hence proved. I'm quickly revising it. Okay, we had to show that if x into y is even, then either x is even or y is even. Let P denote the statement xy is even. Let Q denote the statement either x is even or y is even. How do I use the indirect proof technique to prove P implies Q? I show that not Q implies not. If Q denotes the statement that either x or y is even, not Q means that x and y are not even. And if P denotes the statement that xy is even, not P denotes the statement xy is not even. So I need to show that if x and y are not even, then x into y is also not even. So if x and y are not even, it means they are odd numbers. Let them be the form 2n plus 1 and 2m plus 1. 2n plus 1 is an odd number, 2m plus 1 is an odd number, provided both m and n are integers. If I take x into y, it's 2n plus 1 into 2m plus 1, which is this, which I can write like this. This is an even number, this is an odd number, even plus odd is odd, so xy is odd, which means it is not even. So I have shown that if x and y are not even, then x into y is also not even, it's odd. That means I have shown that not Q implies not P is true. If that is true, it means P implies Q is also true, where P is x into y is even and Q is either x is even or y is even. Okay, so this was a good question and an application of symbolic logic. Now moving on to question number 1, part B. If I come back to the question paper, let me first come back to the question paper. Let's look at part B quickly. Show that a tangent to the curve x to the power 2/3 plus y to the power 2/3 equal to 1 at the point x0, y0 can be written in this particular form. X0 to the power negative 1/3 times x plus y0 to the power negative 1/3 times y equal to 1. Use this to show that in the first quadrant, the length of any tangent to this curve is 1. Now, the concept of tangent to the curve is an application of derivatives, differentiation, and I've covered differentiation in quite depth in my introductory mathematical methods for economics for Delhi University students. We know how to find the equation of a tangent. The first thing I need to figure out is the slope. I'm given the curve, I need to find the slope at this point. And then I'm going to use the point slope form to find the equation of a tangent and show that it's equal to this. So let me quickly come to the whiteboard first. Let me quickly write what is given to us. We are given the equation of the curve. The equation of the curve is x to the power 2/3 plus y to the power 2/3 equal to 1. We have to show what? To show that the equation of a tangent, we need to show that the equation of a tangent to the above curve at the point x0, y0 can be written as x0 to the power negative 1/3 x plus y0 to the power negative 1/3 y equal to 1. That's the first thing I need to show. Okay, so let's quickly first of all find the slope. We know we have to use implicit differentiation. So we are given that x to the power 2/3 plus 2/3 plus y to the power 2/3 is equal to 1. So the first thing I need to do is I need to differentiate it. So differentiating implicitly with respect to x. Implicit differentiation I've covered in quite depth in my course on differentiation within the mathematical methods for economics. So differentiating implicitly with respect to x, the derivative of x to the power 2/3 is 2/3 x to the power 2/3 minus 1. The derivative of y to the power 2/3 is 2/3 y to the power 2/3 minus 1 times. Remember, y itself is also a function of x. So dy by dx equal to the derivative of 1 is 0. So what do I get? I get 2/3 x to the power negative 1/3 plus 2/3 y to the power negative 1/3 times dy by dx is equal to 0. So I get 2/3 y negative 1/3 dy by dx is equal to negative 2/3 x to the power negative 1/3. How did I get this? I just took it to this side. Now, what do I get as dy by dx? dy by dx is nothing but negative 2/3 x to the power negative 1/3 over, I can take this term in the denominator here. So 2/3 y to the power negative 1/3. Remember, this term goes in the denominator. 2/3 cancels out. What do I get? I get negative x to the power negative 1/3 over y to the power negative 1/3. If I want to make the powers positive, I can just flip the terms. If I take y to the power minus 1 by 3 on the top, it becomes y to the power 1 by 3. And if I take x to the power minus 1 by 3 in the bottom, it becomes x to the power 1 by 3. The reason I'm doing it is because I want to make the powers look positive for simplicity. So this is my dy by dx, which I also call as m, which is the slope of the tangent. Now, specifically at the point x0, y0, we need to find the equation of the tangent at the point x0, y0. That means I need to find the slope at x0, y0. The slope at the point x0, y0 will be, in this expression, put y as y0 and put x as x0. So this is my slope at the point x0, y0, which I call as m. Now we are given the point. The point is x0, y0, and the slope, which is m, is negative y0 to the power 1/3 over x0 to the power 1/3. How do I find the equation of a tangent? So I can write equation of the tangent using the point slope form. Using the point slope form is, I cover the point slope form in my lectures on coordinate geometry. How to find the equation of a straight line? It's y minus y0 equals the slope m times x minus x0. Now guys, what is m? Just substitute the value of m. We have just found out it's negative y0 to the power 1/3 over x0 to the power 1/3 times x minus x0. All I have to do is now rearrange terms. So I can now multiply. I can just take x0 to this side and multiply. So x0 to the power 1/3 times y minus y0 is equal to negative y0 to the power 1/3 times x minus x0. And now if I just multiply it throughout, I get x0 to the power 1/3 times y minus x0 to the power 1/3 times y0 equals negative y0 to the power 1/3 x. And this minus will make it plus y0 to the power 1/3 x0. If I rearrange the terms, this is a negative term. I can take it here to make it positive. This is a negative term. I can take it here to make it positive. So if I rearrange, I get x0 to the 1/3 y plus y0 to the 1/3 x is equal to y0 to the 1/3 x0 plus x0 to the power 1/3 times y0. Okay, so this looks like this. I can write y0 1/3 x plus x0 1/3 y. I wrote this first and then I wrote this to make it look like what I want to show it. And here I can take x0 to the power 1/3, y0 to the power 1/3 common. Why am I doing it? Because if I do it, see inside the brackets, what do I get? Inside the bracket, I get x0 to the power 2/3, because x0 to the power 2/3 and x0 to the power 1/3 will make it x0. And here I get y0 to the power 2/3, because y0 to the power 2/3 and y0 to the power 1/3 will just make y0. So basically, students, in this whole expression, the trick I used is I took x0 to the power 1/3 and y0 to the power 1/3 common. Why I did it? Because inside the bracket, I want to create this, and you can see that this is 1. Why is it 1? Because if you read the question carefully, the curve is tangent at this point. That means this should satisfy this equation. X0 to the power 2/3 plus Y0 to the power 2/3 should be equal to 1. Because if I have to find the equation of a tangent to the curve at this point must satisfy this equation, right? That means x0 to the power 2/3 plus y0 to the power 2/3 should be 1. And if it should be 1, it means that this is 1. This whole thing is 1. So this implies y0 to the 1/3 x plus x0 to the 1/3 y is equal to x0 1/3 y0 1/3. And if I divide the above equation by dividing the above equation by x0 to the 1/3 y0 to the 1/3, what do I get? Y0 to the 1/3 x over x0 1/3 y0 1/3 plus x0 1/3 y over x0 1/3 y0 1/3, and the right hand side also gets divided by the same term, x0 1/3 y0 1/3 over x0 1/3 y0 1/3. Now students can see this and this cancel out, this and this cancel out, this and this cancel out. So I get x over x0 1/3, which is x0 to the power how much? I get x0 to the power 1 minus 1/3, which is 2/3. Okay. And similarly, what do I get? Okay, let me correct myself. I cannot cancel x because this is x0. So let me make this correction. I cannot cancel, guys, because this is x and this is x0. So what I get is x over x0 to the 1/3 plus y over y0 to the 1/3 equals 1, because this and this cancel, giving me 1. Now x0 to the 1/3, I can bring it in the numerator and I can write as x0 to the negative 1/3 times x. Y0 to the 1/3, I can take it in the numerator and I can write it as y0 to the negative 1/3 times y equal to 1. This is what we had to prove. See, if I scroll up, what do I have to show? I had to show that x0 to the negative 1/3 plus y0 to the negative 1/3 times y, x0 to the negative 1/3 times x plus y0 to the negative 1/3 times y should be equal to 1. I need to show that this is the equation of a tangent. I have shown that. This is the required equation of the tangent. If I just quickly sum up the whole process again, okay, we were given the curve. I had to find the equation of a tangent at the point x0, y0. To find the equation of a tangent, I first need to find dy by dx. I need to find the slope. I start with the equation of the curve given to me. I implicitly differentiate it with respect to x, where y itself is also a function of x. I rearrange the terms, I find dy by dx. This is the dy by dx I got. I evaluate dy by dx particularly at the point x0, y0 by putting y as y0 and x as x0. This is the slope I got at the point x0, y0. I have the point, I have the slope. I know how to find the equation of a straight line using the point slope form. Y minus y0 is m times x minus x0. Something we even learned in class 12th economics, class 12th maths. How to find equation of a straight line. I just plug in the value of m as negative y0 to the power 1/3 over x0 to the power 1/3. I rearrange the terms. Then I did the trick. In this expression, I just took x0 to the power 1/3, y0 to the power 1/3 common. This was tricky because inside the bracket, I am left with this, which is 1. Why is it equal to 1? Because at the point of tangency, the curve and the point should lie on the curve. If the point x0, y0 lies on the curve, it satisfies the equation of the curve. That means this was 1. This was 1. which gave me this. And if I divide both sides by x0 to the power 1/3, y0 to the power 1/3, I get this, which after simplifying gives me the required equation of a tangent. So it was a tricky question because it involved a lot of algebra along with implicit differentiation. And then what was the next part asking us? To show that the length of the tangent in the first quadrant is equal to 1. Now to find the length, we need to use the distance formula. How do I use it? I first find the x-intercept and the y-intercept. To find x-intercept, I put y as 0. We put y as 0 in, call this as equation star, in equation star. If I put y as 0, I get x0 to the negative 1/3 times x plus 0 equals 1. Because if I put y as 0, the whole thing is 0. So what will x be? It will be 1 over x0 to the negative 1/3, which is x0 to the 1/3. So my x-intercept is, so the x-intercept, call it as point coordinate A. The coordinates of point A are x takes the value x0 to the 1/3 and y takes the value 0. Similarly, students, to find the y-intercept, we put x as 0 in equation star. That means in this equation, put x as 0. So I get 0 plus y0 to the negative 1/3 times y equal to 1, which implies y is 1 over y0 to the negative 1/3, which I can write as y0 to the power 1/3. So the y-intercept, which I can call as the point B, has coordinates x is 0 and y is y0 to the 1/3. Now using the distance formula, how can I find AB, the length? Length AB using the distance formula is, remember how we use the distance formula? It is this minus this square. Again, I've covered this in coordinate geometry. Plus this minus this square. Using the distance formula. Okay, we have done the distance formula in high school mathematics as well. How do we use the distance formula? To find AB, distance AB, this coordinate minus the corresponding x coordinate for B squared up, plus this coordinate minus this coordinate squared up. So my AB is going to be square root of x0 to the 1/3 square plus y negative y0 to the 1/3 square. Okay, and this is going to be x0 to the power 2/3 plus, remember the minus will vanish if I square up, and 1/3 times 2 is 2/3. Now we just said that x0 to the power 1/3 plus x0 to the power 2/3 plus y0 to the power 2/3 is 1, right? We just said it in the beginning. See, if I scroll up, look at this. x0 to the power 2/3 plus y0 to the power 2/3 is 1. That means I get my answer. It is square root of, this whole expression is 1 and square root of 1 is 1. So I get my length AB as 1, and this is what I had to show. See, length of the tangent in the first quadrant is 1. This is what I had to show. So I use the distance formula to find the distance formula. To use the distance formula, I first found out the x-intercept A and the y-intercept B. Once I got the x-intercept and the y-intercept, I directly used the distance formula. And I got this, which is equal to 1 from the beginning. That means the length, or I can say the length of the tangent in the first quadrant is 1. Hence proved. So with the students, we are also done with question 1 part B. Now in the next lecture, I'm going to look at question 1 part C. We have done question 1 parts A and B. We are going to solve part C in the next lecture. I stop in this lecture. I hope students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp. or you can mail me your doubts at divineschoolof economics@gmail.com. This is where I stop in this online lecture.